Hello, welcome back. Ready for part 2 of section 6, all about the laws of logarithms. Alright, we're going to review real quick before we jump into solving equations and things like that. I want you to find the log in base 2 of 32. Now hopefully you can just do this in your head by now. Remember, as soon as I ask for a log, I'm asking for an exponent. What exponent makes this true? 2 to what power equals 32? Answer: 5. Now, if you weren't sure about that, here's what you could have done, and I want you to write this down. You could have said that this is really just the log in base 2 of 2 to the 5th power. Well, wait a minute. When you have the log in base 2 of 2, you just get whatever's left, which is 5. You could have also done this. You could have said, all right, 2 to what power equals 32. That's another way you could have done this. Well, 2 to what power equals 2 to the 5th power? But by 2's, x equals 5. Therefore, the answer is, again, just 5. Either way, doesn't matter. Now, over here, we're going to do natural log. Now, instead of base 2, natural log is always in base e. You can think of this as the log in base e of e to the 4th power. And guess what? Since you have the log in base e of e, you can just cross them out and you have 4. That's the answer. You could have also thought about it like this. Well, this is base e, so it's e to some power equals e to the 4th power. Well, since you have the same base, but by e's, x would just be 4. Therefore, the natural log of e to the 4th, which is what we started with, is just 4. So the point is, the natural log of anything is really just the same as the log in base e of that same thing. Very important concept. So what I want you to do now is to find the natural log of e and to find e to the natural log of x power. So let's think about this. The natural log of e. Well, we don't know what it's equal to. We're missing a piece of the puzzle, so let's just put an x there. Now rewrite this in exponential form. What's the base? What's the base? Remember, we just talked about this. The base is actually e. There's a little e right there. So it's e to the x equals e to the 1st power. Well, that means x must just equal 1. Well, that means the natural log of e must just equal 1. Very, very important right here. Put a box, put a star, put a happy face, and I want to introduce you to your new friend. Your new friend is Lenny. Lenny lives a pretty sad life. Because anytime Lenny shows up, you just cross him out. You know why? Because Lenny equals 1. And he always goes away. Poor Lenny. We'll meet Lenny several more times before this lesson over. He always tries to show up. But then we always say, Lenny, get out of here. Alright, now I want you to evaluate e to the natural log of x. Well, since we don't know what that's equal to, let's set it equal to some number y. Alright, now this is an exponential equation. What do you think I want you to do with it? Since it's in exponential form, let's write it in logarithmic form. So it's the log in base e of what? The answer was y equals the exponent. Remember, a logarithm is always an exponent. Well, that just means that the natural log of y, because this just says the log in base e, equals the natural log of x. Well, what does that mean? That just means that y equals x. Think about this. That means what, folks? We already know what y was. Y was just what? Y was e to the natural log of x. They were the same. So, wait a minute. You're telling me that means, Mr. Williams, that e to the natural log of x equals x. From right here, it's just a substitution law or property. Oh, well, that's kind of silly. That just means the E and the ln just kind of go away, and I'm left with whatever's left there. Well, that's true. Here, I want you to introduce you guys. You remember how we had Lenny over here? I want to introduce you to his girlfriend. It's Ellen. And Ellen always just kind of goes away too. So Lenny and Ellen, unfortunately, they make a good couple, but they always go away. All right, they always try to show up, but then they go away. So let's use what we've learned about Lenny and Ellen and see if we can simplify a few natural log expressions. So here we go. We've got the natural log of 1 over e cubed. Now remember, a natural log is just another way to write any kind of logarithm. It's just a logarithm. So this really says the natural log of what? E to what power? If I make that e in the bottom and I bring it to the top, now he's not happy. He's raised to a negative power. Well, think about that, guys. You have who just showed up? You have Lenny here, guys. Do you see him? Here he is. Guess what always happens to Lenny? He goes away, and you're left with whatever's left. You're left with negative 3. You could have also thought of this as the log in base e of e to the negative 3, if that helps you. That's just equal to negative 3. Or, you could have even done this, okay? Check this out, and maybe you'll like this way the best. Take this little baby and make him a what? Big baby. So it's negative 3 times Lenny. But wait a minute, what does Lenny just equal? Lenny just equals 1. And your answer again is negative 3. Doesn't matter which way you do it, you still end up with negative 3. Alright, check this one out. Letter B. Okay, e to the power of 3 natural log x. Well, what do you want to do to that one? You can kind of use big baby, little baby. See that 3? It's a big baby. It's in the exponent, but you can make it a little baby within the exponent. So it's actually an exponent within the exponent. Well, that's interesting. Well, what do you have now? You have e to the natural log of x cubed. Wait a minute, you have Ellen. Do you see her? There she is. What happens to Ellen? Ellen always disappears. And guess what you're left with? X cubed. So that wasn't Lenny that time. That was his girlfriend, Ellen. But she always goes away, too. Alright, try this one. Try 10 to the power of 3 log 3, or 3 plus log 3. Now, I like this one because there's no variables. That means you can check this one on the calculator. You sure can. Okay? In fact, well, we'll do it after we do the problem. Alright, so you have 10 raised to this entire power. 10 raised to this entire power. What we're going to do something I call the split approach. We've done the split approach before, but we did it with fractions. This actually says, guys, 10 to the third power, right? Times 10 to the log 3 power. That's actually what that says. Think about that. When you have the same base, what do you do with the powers? You add the powers. Well, that's what they've done up here. But we're going backwards. We're splitting it apart so that we can simplify it. Because check this out. You have 10 to the log in base 10 of something. Guess what happens to 10 log base 10 of something? Cancels, and you're left with the something. So we have 10 to the third power times 3. Well, 10 to the third power is 1,000 times 3. Answer? That just says 3,000. This is a fancy way to say 3,000, and that's it. You can check this on the calculator. So let's do that real quick. Get your calculator. Here's mine. And type your original expression in, which was 10 raised to the, was it 3 plus log 3? And hit enter. And looky there, 3,000. We did it right. Nicely done. Okay, get rid of that. Alright, here we go. A couple more that you're going to see on your homework tonight. Express y in terms of x. So that means to get y by itself. That's all that means, is to solve for y. Right now, our y has this log in front of it. Well, what would be a good approach here? What would be a good approach here? Well, let's deal with the right side first. I got a big baby here, this 2. I'm going to make him a little baby. Now, he's only a little baby to the x. So it's the log of x squared plus the log of 8. Excellent. And over here, you get the log of y still. Now, we still don't have y by itself, but we're pretty darn close. Let's see here. Here I've got a plus sign. What does that tell me I can do with the right side? That tells me I can turn 2 logs into 1 log. So this really says the log of, do you subtract or do you multiply or divide x squared and 8? That's right, you multiply x squared and 8. So now it says the log of y equals the log of 8x squared. Now, I love these, folks. Check this out. Do you have the log in base 10 of something equals the log in base 10 of something? Do you have 1 log on the left and 1 log on the right? Yes or no? So guess what you can do? You can say, bye-bye, logs. I don't need you. If the log in base 10 of y is equal to the log in base 10 of 8x squared, that just means y is equal to 8x squared. Do you have y by itself? You sure do. You done. That's it. That expression really is the same thing as saying y equals 8x squared. It's a parabola. This right here is a parabola. That's crazy when you think about it. Alright. Okay, this one's a little trickier because this time you only have 1 log. There's just 1 log on the left side. What's the base? Oh, it's base 10, Mr. Williams. Well, since it's in logarithmic form, guess what we can do? We can switch it to exponential form. What's the exponent? What's the exponent? Is it 3x? Is it minus 1? Or is it the whole thing? That's right, it's the whole thing. So 10 to the 3x minus 1 equals what? Y. And looky there. Guess what, guys? Y is by itself. Technically, you are done. Technically, you're done. Now, I'm not going to let you be done because I want you to write it the nerdy way. I want you to do the split approach. Split 110 up into 2 10s. Because remember, when you have side by side, you add the powers. 3x plus negative 1 is really 3x minus 1. Now, why did that help us? Well, what's 10 to the negative first power? Well, that's just really 1/10. And what's 10 to the 3x power? Well, that's just really 10 to the third to the x. Well, can we clean that up a little bit? We sure can. This really says y equal 1/10 times 1,000, because that's 10 to the third, to the x power. Looky there. That's the way I prefer that you write your answer. Although technically this is the correct answer, I'd rather you write it like this because now it's in the form of an exponential function, and that's technically one of the main concepts that we've talked about in this chapter. Okay, solve for x. Love these kind of problems. Now, when you're solving for x, you want to simplify, simplify, simplify. Make it as simple as you can. So can we simplify here? We've got the log of something in base 6 plus the log of something in base 6. Are they the same base? They sure are. We're adding them, so what can I do with x plus 1 and x? Can I add them or can I multiply them? Oh, that's right, I can multiply them. I can use the product sum law. So this really says the log in base 6 of x times x plus 1 equals 1. You with me there? We took 2 logs and turned them into 1 log. Now what? Well, that really just says the log in base 6 of x squared plus x. All I did was distribute. Now, do I have 1 log or 2 logs? I've only got 1 log. So to get rid of it, I have to get rid of it. I've got to rewrite this in exponential form. Exponential form. So what's my base? Base is 6. 6 to what power? What's the answer? First power equals whatever we were taking the log of, x squared plus x. Can you solve for x now? Sure can. Set this to 0. How many answers are you going to get? 2 answers, Mr. Williams. So that's x plus 3 and x minus 2. Check your answers. What are they? -3 and +2. Are you done? Yes or no? You always have to check your answers before you're done. Remember, guys, when you plug in -3, you end up with this. You end up with the log in base 6 of -3 plus 1, which is really the log in base 6 of -2. What's wrong with that picture? Think about that. That means 6 to some power, I'll call it y, equals -2. When will that happen? 6 to what will ever be a negative number? Never gonna happen. Remember, guys, earlier in the chapter we said you can't take the log of a negative number. So don't just automatically cross out the negative numbers. You have to plug them back in and see if what you end up with is still negative. And in this case it was. It was -2. That's why it doesn't work. So +2 works, but -3 doesn't. It's extraneous. Okay, I think this is the last example for this video, but let's do what we can here. Now on the right side we've got 2 logs. Well, anytime we have 2 logs, we can condense them as long as they're in the same base, which these are, base 2, into 1 log. Would you divide, subtract, or multiply the x and the 6? That's right, you'll multiply those. So that really says the log in base 2 of 6x. The left side remains unchanged. And now the equality log comes into play. Check it out, guys. We've got the log in base 2 of something equals the log in base 2 of something. There's only 1 log on the left and 1 log on the right. So we can say, bye-bye logs. Don't need you. Goodbye logs. You're not necessary anymore. All I need is x squared plus 8, and I need to set that equal to 6x. And now it's a quadratic equation. I just solve it. Set it to 0. Hopefully it factors, which these almost always do. Solutions 4 and 2. You need to check them both. Make sure that when you plug them back in here and here, that you always end up with positive numbers. If not, you got fool's gold. But both of these, in fact, do check. Might want to put little check marks next to them to remind yourself that you had to check them. Have to. And that's it. There you go. 2 answers. Love the equality law. Makes life simple. Okay, that is all I have for this video. Only 1 section left in the chapter. I will talk to you all later. I'm out.